Hey guys, so as we step into this journey of organic chemistry, we have to know some certain things before exactly starting our journey. And so that's what this video is dedicated to. We're just going to talk about some basics that you need to know before starting organic chemistry. I mean, this is still part of organic chemistry, but these are the basics that one must know when going into the depth of it. So, first we've got representing formulas. So, when we're in organic chemistry, we have a lot of formulas, a lot of compounds, and there are different ways to represent those compounds. So, first we've got structural formulas. So, we've got structural formulas. And these formulas are the types of formulas which show all the bonds present. So if I were to take a simple compound, let's say ethane. So ethane is a hydrocarbon which has a simple formula of C2H6, and that's the formula of ethane. Now, if I were to represent this in a structural formula, there are many ways in which I could do this, but right now I'm using a structural formula. So this would be represented by showing each of the bonds present. So this would be the structure or the structural formula of ethane. Basically, we have to show the structure of that compound. Now, if I were to use ethene, which is also another hydrocarbon, so that's C2H4, this would also be pretty simple, and in the middle there would be a double bond and a H, and 4 H's. As you can see, when it comes to a structural formula, I am jotting down every single bond that is present in the compound. So each and every bond is shown in a structural formula. So that's a structural formula. Now, let's go on to the next type of formula. But before that, let's just do a little something. Now, the next type of formula is a condensed formula. So let me just write that down. Condensed formula. And as the name suggests, it is condensed. It's like a short form of, a structural formula. And if we were to write the condensed formula of the same ethane and ethene, then we would get something similar to these two, but all the bonds will not be shown. So let's see. I'm going to first write ethane, which is C2H6. And this would be our condensed formula, CH3, CH3. That would be a condensed formula. And then we also got ethene, just C2H4. And this would be CH2 double bond CH2. So these would be condensed formulas. If we were to go with more bigger examples, let's do these two, structural and condensed. We'll do one big example for them. Or better yet, we'll discuss that example at the end. So right now we're only going to discuss it for ethene and ethane, and then at the end we'll give some bigger examples. Okay. So the third type of formula that you could look out for are called skeletal formulas. And these formulas are just describing the basic structure. So the basic structure without showing most of the bonds. Only the bonds between carbons and other atoms other than hydrogen are shown here. So skeletal formula. So yeah, let's draw some skeletal formulas. For example, if we were to take ethane again, which is C2H6, that would be just this. This would be a skeletal formula for ethane. Now, ethene, which is C2H4, would just be this. So skeletal formulas just show the bonds between carbons and other atoms other than hydrogen. So if you look at the difference between these three so far, you'll see that in structural formulas, you're showing every single bond. Every bond, including the ones between carbons and the one between carbon and hydrogen. And if there were other atoms too, like oxygen or nitrogen, you would also show those bonds as well. In condensed formulas, you would show just the number of atoms, or in this case, like for example here, we're showing the bonds between groups, but we're not showing the bonds that are present in the groups. So that you could think of it that way. So that's a condensed formula. And in a skeletal formula, we're not even showing those groups because it's kind of implied. So, I mean, if you think about it, carbon can only make 4 bonds. And usually if the atoms that are in organic chemistry, if the atoms that are attached to carbon are not shown, especially in a skeletal formula, it implies that it's bonded to a hydrogen. So when they're not shown, like in this case, in ethane, we only showed 1 bond between carbon and carbon. There are still 3 other bonds on each carbon, or in ethene's case, 2 bonds on each carbon that are not shown. So when they're not shown, we just automatically assume that they're bonded to a hydrogen atom. So that's skeletal formula. Skeletal formula only show the bonds between carbons and other atoms like oxygen, but not hydrogen. Condensed formulas show the bonds between groups, and structural formulas show every single bond. Now let's move on to the next type of formula, which is a bond line formula. So a bond line formula. And as this, kind of implies, it just shows the bonding and as a form of line. So, I mean, it's pretty straightforward, honestly. I mean, you can't really see anything much in the structures of ethane and ethene, but we'll see. C2H6. This would be represented as just a line. So, I mean, okay, this is not a really good example, but for the sake of, comparison, I'm using ethane and ethene. C2H4, and this would be a double bond. Now, when we get to the bigger example, you'll see what exactly, makes these different. But here in a bond line formula, all the edges, or like the points, the pointy stuff, and the ends of the formula represent carbon atoms. And any other atom that you insert in between, like oxygen or nitrogen, those will be, represented separately, like an O for oxygen, N for nitrogen. Those will be represented, but when you're considering the bond line, those are only used to represent carbons. And obviously the hydrogens are implied, like in a skeletal formula. So yeah, those are the 4 types of formulas that can be used to represent an organic compound. So let's go for a bigger example here. I'm going to use some example. Okay, this may not be that big, but it can show you what the different things are. So I'm going to go with two examples. One is an alcohol, and we'll go with something that you probably know, which is propanol. So propanol is an alcohol, and its formula is C3H7OH. That's the formula of propanol right there. So we're going to go with this example. And so first we're going to draw, let's just move this over here. Okay, so we're going to draw the structures of, not the structures, the formulas of propanol. So this is just a basic formula, but we're going to draw the structural formula, the condensed formula, the skeletal formula, and the bond line formula. So we're going to do all of those for this single compound, and then we'll move on to another one. So when we're discussing propanol, we see that there are 3 carbons. So first we're going to do a structural formula. So we have 3 carbons, and these 3 carbons are bonded to each other. So we're going to show it like this. Now, we're going to assume that the oxygen and the H group is attached here, and that we just have to fill in all the other hydrogens. So there are 7 other hydrogens left. So this is a structural formula of propanol. See that even in the alcohol group, this thing here is called an alcohol group, and even in that too, we are showing the bond between oxygen and hydrogen. Writing this as OH would be a correct formula, but it's not a structural formula, if that makes sense. That will be shown in different formulas, but not in a structural formula. In a structural formula, we show every single bond. So that's that. And that's a structural formula. Now let's move on to a condensed formula. In a condensed formula, we're showing the bonds between the groups. So we could write it like this. So here, let's talk about the groups here. So we've got this, then this, and then this, or you could just talk about this as a whole. But either way, these are the things that we have to mention separately while talking about our condensed formula. So let's see. This could be written as CH3, CH2, CH2OH. You could write it like that, or you could put it like this too. That's your choice. But yeah, this is how you could write it. You could also do CH3, CH2 twice OH. That's also possible, because it shows that this CH2 thing is happening 2 times. That's what this implies. So you could write it like that as well. So yeah, condensed formulas have a lot of different ways to be written. But the main idea is that you're not showing all the bonds. You're just showing all the atoms present. Now let's go to the skeletal formula. So when we're talking about a skeletal formula, as I've mentioned before, we only show the carbons and other atoms except hydrogen. So, in the case of carbon except hydrogen. When we're talking about alcohols, obviously we need to show hydrogen because, if you don't put the H, you don't know which group it is. So there are C, 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 and OH. This would be a skeletal formula It's pretty simple, and for someone who has studied organic chemistry, it's the easiest way. Okay, not the easiest way, but it's a pretty simple way to write a formula. Normally, we don't do this, like, it's a waste of time, but either we use this, which is sometimes, or this. And the one that I use the most is a bond line formula, which is pretty simple because it's easy to draw and interpret. So if we're doing a propanol structure, we have 3 carbons. That means there has to be 3 carbons present in our bond line structure, which includes the ends of the line as well as the vertex. So if I were to do this, that would be wrong because these are the ends of the line and there are only 2. There are no vertices present in between. So the only thing that we consider is the ends of the line in this case. And that would be wrong because there are only 2. But if I were to continue, let's say, wrong color. Let's say I do this, and then I bring it down like this. Now here, this would be correct because there's one end here and another end here, so that's 1, 2 carbons. And then there's also a vertex present in between. So overall, we've got 1, 2, 3 carbons. Now in propanol, as we've discussed, the formula is C3H7OH. So there are 3 carbons present in my bond line structure. So that's that. Now, let me erase this. This is our bond line structure. Alone, it just represents propane, but we have to represent propanol. So what we're gonna do, put the OH in the same place, so this would have an OH here. So this is propanol because there's 1, 2, 3 carbons, there's an OH group, and when we're counting the hydrogens, there's 1, 2 here, 2 here, 1, 2, 3 here. So that's 3 plus 2 plus 2, which is 7 hydrogens, and 7 hydrogens, 1 OH group, and 3 carbons, which is the formula. So that's how you can draw a bond line structure for propanol. And here are all 4 formulas for propanol in this case. Now let's move on to another one. This is the last example. We're gonna use ethanoic acid. So, ethanoic acid, or commonly known as acetic acid, but it's fine. We don't need to mention that here. So, ethanoic acid, the formula of ethanoic acid is CH3COOH. So that's the formula. Now we've got to write the structural formula, the condensed formula, the skeletal formula, and the bond line formula. So if you want to, you can pause the video to try and draw the the formulas by yourself, or if not, you could just continue watching. But either way, this can actually be asked in the JEE main examination, because when I wrote the JEE main examination, they directly asked which of the following is a correct structural formula, or which of the following represents a structural formula. They do ask that, by the way, so it could be a valuable 4 marks in your JEE main examination. But yeah, I'm just saying, don't take this light. Take it seriously because it actually matters. So, anyways, so let's continue. So structural formula, as I said before, we're showing every single bond. So let's just get started here. So there's a C and another C, the basic. Now here, what we're gonna do is we're gonna show every single bond. So this is at CH3 at the beginning. Now, this COOH group is actually present in this way. That's the COOH group. Now, if we were to draw this in a structural formula, you would just do the same, except you have to show this bond as well. So yeah, this would be a structural formula for ethanoic acid. So let's now move on to the condensed formula. Now, obviously, that CH3 will be represented by itself, and you could just do COOH. That's pretty basic. That's our condensed formula here. Now, some weird people, I just find this weird, like to do this, but I hate this. It doesn't make sense. It's probably because I'm used to this. But yeah, just do this. Now, let's move on to the skeletal formula. Now, the skeletal formula, once again, pretty basic. All we have to do is show the bonds. So either you could do this, or actually, not this. You could just do this. Pretty basic. Or you could do this. Once again, based on your comfort. Now, for a bond line formula, we just have to show everything. So there are 2 carbons here, which means the 2 ends would be sufficient. So yeah, you could do this. And then at the other end, there's an OOH group, right? So you could do this. So here, there is a carbon, and here, there's a carbon. That's what those 2... Okay, this is kind of drawn weird. What you could do is... Let me draw this better, actually. This would be a bond line structure for ethanoic acid. So there's 2 carbons here, right? So that would be that. There are some people who also like to do this. That could also be another way that you could do it. Your choice, honestly. So yeah, most of these structural things, or the way of writing formulas is basically dependent on your comfort. The only thing that doesn't change no matter what is the structural formulas, because those are bonds, and you can't really change bonds for your comfort, right? So those things are the same, but condensed formulas could be represented in different ways. And for some skeletal formulas, it's the same, but for other types, you could either expand the whole thing or condense some of it, like how we did here and here. And same thing for bond line formulas. So, yeah, those are the different kinds of ways of representing formulas. And this is just a step to starting organic chemistry, and a way to effectively communicate some of the bonds and the compounds that you'll be working with. So that's it for this video. We'll see you in the next one.